Over these past years, there has been changes to our education system. GS has introduced a new curriculum which all basic schools are using as of now. And this new curriculum came with a lot of changes to the subject. One subject that received a lot of change is ICT, which now is no longer in existence. We don't have ICT anymore. Now what we have is computing, which is basically the same thing but a bit advanced than what we were taught during our time. I studied ICT, but now kids in JHS are studying what we call computing, and it is a bit advanced than what we were taught during our time. So this series is called Computing 101, where I'll be giving lectures on the various strands and substrands in the new computing curriculum. Let's get into it. Computers have really come a long way. I mean, from the first generation of computers, we now have the fifth generation of computers. First generation of computers use the vacuum tubes. The second use transistors. Third generation also use integrated circuit. The fourth generation of computers is using microprocessors, which is basically like 1,000 times, or let's say 1,000 components of the integrated circuit. Yeah, and now on the fifth generation, it is based on artificial intelligence. So when we look at the first generation, which was very big and bulky, in less than 50 years now, we've moved from that big and bulky computers to having our computer in our palm. After the fourth generation of computers, which used a very large-scale integrated circuit, the fifth generation of computers was also introduced, and that used an ultra-large-scale integrated circuit, which is a very advanced version of the very large-scale integration. The primary goal of the fifth generation is to create machines and systems that can learn and organize themselves. This includes robotics, neural networks, and expert systems for decision making. These machines and systems are able to interpret human language as well as recognize graphs and photos, thanks to AI technology. So now, let's look at the advantages of the fifth generation of computers. One, they are quicker than the previous generation of computers. The fifth are very, very faster. They are able to predict and also learn more than the fourth generation of computers. Parallel processing has also progressed with the fifth generation of computers, and then it is more accurate and fast. And one thing I like about the fifth generation of computers is the fact that they always keep making it small. So we move from the first generation, which was very, very big computers that will be sitting on your decks, to now having something as small as a smartphone, which has a lot of processing power than the first big computer that was sitting on our desks. Disadvantages of the fifth generation. One, it is very sophisticated and complex to use, and it's very expensive. Yeah, that's one thing. Another thing too is the fear of losing jobs. As technology keeps advancing and it keeps progressing, now we have AI that basically does almost everything human beings can do, from writing scripts to generating videos to even generating videos from just text. People have this perception that AI might take their jobs, or they might end up losing their jobs to AI. So this is kind of like a disadvantage to the introduction of the fifth generation of computers. And in some sense, yes, it is correct, because if AI can do the work of 10 people, why would you want to hire 10 people to do the work whilst AI can do the job just at once? I mean, it will save you money and also save labor. So people fear AI might be taking their jobs. Now let's go to the second aspect of components of the computer. On this aspect, we have quantum computing and parallel processing, which are basically features of the fifth generation computers. Now, I'm sure some of you have heard of the word quantum physics or even quantum realm in movies. And you've wondered, what is quantum computing, or what is the quantum realm, or what is quantum physics? So the word quantum is actually the study of how energy and matter works at a subatomic level. Now, what is a quantum computer? A quantum computer is a machine that uses the unique properties of quantum mechanics to solve problems that are too complex for regular computers and even supercomputers. And the field of quantum computing focuses on developing technology that takes advantage of how energy and matter behave at a subatomic level. Quantum mechanics is the study of how the behavior of subatomic particles such as electrons, protons, and neutrons to make sense of how the smallest things in nature work. In regular computing, data are measured by bits, but in quantum computers, data is measured in qubits. Quantum computers measures data differently than regular computers. As I said, quantum computers measures data in qubits, whilst regular computer measures data in bits. So what this means is, quantum computers is able to process information, whether it's 0 or 1 at the same time. So it is simultaneous. It processes the 0 and 1 at the same time, which is the binary unit for computing. But with the regular computers, it only measures data either 0 and 1 at a time. It doesn't measure that data at the same time, unlike quantum computers that can do it at the same time. Now let's look at the uses of quantum computing. Now, we use quantum computing for molecular modeling, which is to simulate the behavior of molecules and atoms. We also use for database searching or data mining, which is to store and search through massive amounts of data in a very quicker time. There's also cryptography, which is to break complex forms of encryption, which is useful for cyber and network security. So with the cryptography, it normally helps companies to be able to strengthen their security system or help to crack encryption that has been placed on their security system. Another use of the quantum computing is weather forecasting, which is to predict the weather conditions more accurately than regular computers. When we look at the advantages of quantum computers, they are faster than regular computers and even supercomputers, and they can solve complex problems better than regular computers. They also run complex simulation. So in a scenario where we want to predict a given outcome, or we want to predict a scenario, quantum computers are able to do so much better than regular computers and even supercomputers. But when we look at the disadvantages of quantum computers, one, it is very difficult to build. And this is because the components of the quantum computers are very expensive. It is not like regular computers that come all packaged with your inputs and output devices and everything you need. With quantum computers, you have to build them up. So you have to buy the separate components and then build them. And the higher the processing part of the component is, the higher your quantum computer also is, in terms of power. Another disadvantage of quantum computers is it is prone to errors. Because of their quick processing time, normally end up making errors. So if you don't pay attention to the processing, you end up with a lot of errors. Also, it is suitable for specific tasks. Unlike regular computers where you can use them for numerous tasks, quantum computers is only limited to a certain specific task. So what supercomputers can do, it does it faster, but not everything that a supercomputer and regular computer can do is what quantum computers can do. They only do a specific task given to them, which is a disadvantage to them. Now let's look at parallel processing. Parallel processing is the simultaneous use of multiple processors to execute the same task, but to obtain a faster result. So what this means is using two or more devices or processors to execute the same task, you are going to have your results in a quicker time, unlike using just one. So let's assume your school has a printer, and one printer is able to print 100 copies of work in an hour. When you have 3 printers, with that same hour, you'll be able to print 300 copies, which is a better result or a much productive work than using just one printer. Programs are divided into small independent parts and can be executed simultaneously by separate processors. It is used in supercomputers for processing large amounts of data. When we look at the advantages of parallel processing, one, it saves time. Because if you are using 3 processors to perform the same task or to execute the same task, you end up finishing your work in a very quick time, unlike using just one processor. So in this case, using 3 printers to print your school's work, you are going to finish the work in a very short time. But if you are using just one printer, it's going to take a bit long. Another advantage of the parallel processing is it solves large problems in a short time. It also has massive data storage and quick data computation. Also, using multiple computing resources to do many things simultaneously. When we come to the disadvantages of parallel processing, one, it has a high power consumption. And this is due to the fact that you are using multiple processors to perform or to execute your tasks. If you're using just only one, the power consumption wouldn't be more as using 3 or 4. Another disadvantage is also it requires expensive cooling techniques. Because machines and processors tend to overheat when they are in use, you need to have a cooling technique for your processors. So if you have 3 processors that you are using, that means you have to have 3 cooling techniques for each of them to be able to continue and work effectively for you. Another disadvantage is hard to implement because it's very expensive. Imagine the price of one processor and looking at 3 of them to be able to perform your tasks. So it is very expensive and it's very hard to implement. Also, it requires different models and also programming. These are some of the disadvantages and advantages for parallel processing. Now, let's go to the last aspect of our topic for today, which is artificial intelligence. Artificial intelligence software is any software that is designed to think intelligently like the human mind. This software learns patterns in data and uses them to make intelligent decisions on a given data. Now, there are types of artificial intelligence software. We have the AI platforms for developing apps from scratch, and we have chatbots like ChatGPT and some of WhatsApp's AI, the Llama, and we have deep learning software also, which is for speech recognition, image recognition, and social recognition. So with this one, like our phones that normally have Face ID and stuff, that's the deep learning software for it. And we have a machine learning too, machine learning softwares. These are all types of AI softwares. And examples of AI software include the Google Learning Software, Cortana, Amazon Alexa, IBM Watson, and I think Apple Intelligence is also in right now with Samsung Galaxy's AI also on the way. WhatsApp's Meta 3 is also there, and a lot of AI softwares we have now. So this brings us to the end of our lesson for today and our components of the computer and computer system. I'll be doing a part 2 to this video to talk about the direct data entry devices. So if you are new to this channel, please make sure to subscribe and turn on the notification bell to stay up to date when we release another content. My name is Kendrick Brown, and this is Computing 101. See you on the next one.